This is my implementation of the instruction memory for the processor. The instruction memory is implemented as a ROM, as we can see here. It takes one input, that is A, which gives the address of the memory location to be accessed, and the output is RD, which gives the accessed instruction. Width of the memory is 8 bits, so 4 contiguous locations will contain one instruction. We can initialize the instruction before synthesis as we need. Let's see the simulation. Once we enter the address that needs to be accessed in A, we can get the access instruction in RD, which is the output. Here we can see the value that we initialized it to. This is my implementation for the data memory of the processor. It is implemented as a RAM. Width of the memory is 16 bits. It takes the clock input, ALU result as an input for the address to be accessed, write data for the data that is to be written to the memory location, write enable, which is 1 if you want to write to the memory and 0 if you want to read from the memory. Mem to reg is a signal that indicates what data is sent to the RF, the ALU result directly or the data read from the memory. The result is the actual output of the block. Let's look at the simulation. In the first two runs, we are specifying the address and the data that is to be written, and we are putting write enable as 1. The output in this case will be the data which is written, because this design implements write before read. In the next runs, we make write enable 0, so we are indicating to read from the memory. When we give the same address that we previously gave, we get the data that we had first initialized.